This is our 51st lesson on the study of the flood. I know it's lengthy, but I'm trying to do a very thorough treatment of the subject. And so in this lesson, we'll be continuing the chapter that we've been looking at. We're going to deal with how do scientists date things. Now, the dating of things is kind of interesting when you get studying how things can be dated. How do we measure time, for example? And so how is time measured? And so that gets very interesting. I remember when I first studied physics and when I was a young pup, it was real hard to define time. And at first it kind of threw me and I began to see. So they use several interesting things to define time, but we'll look at that. Look at this. There's two basic systems of dating things. That is, there's relative dating. For instance, I remember the year my oldest child was born, 1968. Then I add the difference in the age of my children to get the years of the other children's births. Kind of, that's relative. Of course, I memorized the year they were born, but you can do that and get the relative ages of someone. I can look at, I went to a little country school and I knew the children in the first grade all the way through the 12th grade. It was a small school. And they were families that lived in the area most of them all their lives. And so I can say, okay, this child is 4 years under me in school, so he'd probably be 4 years younger than I am, approximately. That's a relative age. So I can get his or her age due to their placement with regard to me. Or I can say someone was in a class in school was one of my older siblings or my younger sister. And I can date them by the ages of my siblings. So that's a relative age. We get one thing relative to another. We have absolute dating, such as the rotation of the Earth around the sun. We get a year out of that. And so we date that as a year. That's some absolute dating. So there's two ways of dating. We'll be looking at both of these and see some problems with it. Now, we have the period of dating things. Correlation on the basis of climatic changes, particularly important for quaternary stratigraphy, whereas climatic changes have evidently taken place much more rapidly than the organic evolution, of which correlation depends for other periods. So wait a second. How are they dating this? Is it absolute or is it relative? I've underlined it here. I think you have to draw the conclusion this is a relative dating that they've used. How they dated? They correlated it with the organic evolution. So right here now, the organic evolution on which correlation depends for other periods. So the dating of this thing is based upon their theory of organic evolution. That'd be organic macroevolution. So this is a relative dating. So if how they dated it was wrong, then we got a problem. For instance, if one of my siblings, one of my brothers or sisters, failed a grade in school, then my dating of their people they graduated with from school would be off by 1 year. And you could look at that. There might be a child whose his age was such that he was ill and didn't start to school till later. And so he would start later and he would be older. And there were different times when school started. I remember September the 1st was the dividing line for when you got in, and then earlier it had been November. One of my older brothers he was 21 months older than me, but he was only 1 year ahead of me. And he started, and I think the cutoff date for them was November. And so his birthday fell such that he started at a different time than I did. So the periods, and so again, you're off only by about a year, but there's an error in the dating with this, and so the quaternary period back up with the footnote on it, the blue footnote, is a period of uniformitarian geology which runs from the end of the tertiary to the present time. So now what we have here is they're dating it, but they're dating it by uniformitarian geologic assumptions. So we have uniformitarian assumptions here we're using for dating. So be aware of that. We're going to keep pointing this out, that much of their dating is based upon uniformitarian assumptions. And as I pointed this out very early in this study of this flood materials, that they have rejected uniformitarianism, substantive uniformitarianism. They've rejected it, and yet they're using uniformitarian arguments to date things. And that's critical, that you understand there's a flaw in their reasoning. They're using a system that they have rejected in order to date their system, to date things. The assumption is also made here that organic macroevolution has occurred. It is part of the assumption of this dating of these formations. The rock formations are then dated based upon the supposed time required for organic macroevolution to occur. So that's an assumption. They first assumed the macroevolution occurred and then said it took millions of years for this to occur. So these rocks must be that old. That's how they've dated. If organic macroevolution has not occurred, the whole system of dating is flawed. So the circular reasoning, they've assumed macroevolution, organic macroevolution, then they've dated it, and then they've used that dating to say, look, this proves that macroevolution occurred because look, this millions of years, or billions, or hundreds of millions of years. So that's an assumption. It's circular reasoning on their part. The only absolute dating system that scientists have set up is radiometric dating. But we've already pointed out the flaws in radiometric dating. In this series of studies, we've already set forth serious problems with radiometric dating techniques or systems. And we've already laid those out earlier. Radiometric dating then is calibrated. Now, when you calibrate something, you adjust it by some other standard. And so again, even that becomes relative because they calibrate it by the fossils. They generally calibrate with fossils, will prove that, which are based upon uniformitarian geologic assumptions and organic macroevolution. So again, we keep coming back to uniformitarianism. They just can't get away from it with their system. They've made that basic assumption of uniformitarianism, which gives them millions and perhaps even hundreds of millions of years of time, upwards of 1 billion in some cases. And then they, with that assumption, they date it, and then they argue, look at all this time, this gives us the time for organic macroevolution to occur. And again, they have a serious problem because one of their essential assumptions that they have is organic macroevolution, and another serious assumption is uniformitarian geologic assumptions. Let's look at our half-life equation again, as we looked at it earlier. N sub t is n sub o e to the minus lambda tau, or t. And n sub t is the quantity remaining after time t. N is the number, see, of a quantity, and t is for time. N sub o is 0, or time 0, beginning time, the initial time. The initials on your name are the first letters, see, the initial quantity, the beginning quantity of the substance. And this will be a radioactive substance, or it can decay. Lambda, and then the Greek lambda here, is the decay constant of the substance itself. And of course, T is the time it took after the beginning of the decay process. Now, understand here, they can measure N sub T but they can't go back in time and measure n sub 0. They have to assume a value for it. Epsilon E, or the base for Neperian or natural logarithms, is a known quantity. It's a very important number in mathematics even. But minus lambda, we've shown that the decay constants of some substance have been known to be capable of varying or with, and so the value of lambda is questioned. And of course, they're solving for t. Now notice you have 1, 2, 3, 4 variables, and they know this one pretty much. But we've already shown evidence that can be a variable. Let's say they can measure n sub t pretty accurately, and this is questionable as to whether it's really known. And then they've got another variable. In order to solve for t, you've got to know these 3 variables: n sub t, n sub o, and lambda. And lambda is a little bit shaky. But n sub t, well, we'll give that to them. They've got a good quantity measured there. But you see, they've still got a variable, how much they had at the beginning. And you can assume any value you want and get any value of time, or different values of time in it. So our problem is they have to make an assumption about how much there was at the beginning. Now, remember, we said science has to observe it happening. It's empirical by nature. Nobody was there to observe how much of radium was there at the beginning of the Earth, and no one that was there to tell how much uranium was there, except God, of course. But what we have here is they can't tell you how much there was. They just have to assume it. And it's all based on assumptions. So if you wanted to figure out, so this is a certain value of time, all you have to do is plug in, figure out, but work it backwards to get how much n sub o you needed. So let's make that assumption. It's subject to being dishonest. There are 4 variables, they only know 2 of them. And even lambda might be a little bit shaky in some instances. We've proven there are instances where it can be varied and changed. Now, the decay constant lambda is not as fixed as some claim. We've already shown that in the prior lessons. The initial value of radioactive material is not known. It's assumed. So there is no unique meaning one of a kind or one single solution for the equation. There are an infinite number of solutions. If you assume different values of n sub o, you get a different value of time. There are an infinite number of solutions for the value of time by assuming all different values of n sub o. And even assuming that lambda is constant and fixed. So we have a problem. There's no way they can draw an absolute conclusion and be certain they're right. We had a decay curve drawn from predicted with no unknown factors. Now this is a quote: no adjustable constants, specific activity of ancient mummies, and so the question was to see whether it worked. The research consisted of 2 stages. The first shock Dr. Arnold and I had was that our advisors informed us that history extended back only 5,000 years. Okay, we can't go back more than 5,000 years to calibrate this. That's when our history ends, about 3000 BC. We had the thought initially that we could be able to get samples all along the curve back to 30,000 years. Put the points in, and then our work would be finished. We can calibrate this curve. You read books and find statements that such and such a society or archaeological site is 20,000 years old. We learned rather abruptly that these numbers, these ancient ages, are not known. In fact, it is about the time of the first dynasty of Egypt that the last historical date of any real certainty has been established. So we had in the initial stages the opportunity to check against known, principally Egyptian artifacts. In the second stage, you had to go back into the great wilderness of prehistory to see whether there were elements of internal consistency which lead one to believe that the method was sound. This is Libby. This is the guy that came up with radiocarbon dating. So he's the fellow that got the Nobel Prize for it. This is a quote from him. Libby admits that there's no evidence for a date earlier than about 3000 BC. And there has been recent evidence that showed that some of that's kind of shaky. This is approximately the date of the flood. The author wonders how they arrived at the date of 3000 BC. Perhaps this date was derived from Manthean histories of Egypt, but we'll get back to that at a later time. Roll, this is a book that I purchased several years ago. It's fairly expensive, but I bought it. It's been useful. In 664 BC, Ashurbanipal, king of Assyria, brought an army to Egypt and sacked the sacred city of Thebes. This date of 664 BC is supported by a whole network of interlocking data supplied by various independent sources, including Berosus, Manetho, and the Assyrian and Babylonian chronicles, apostille and Egyptian regnal dates from the monuments. So there's a bunch of sources that date it, and they all come out with about the same date. This is about 664 BC. I want you to notice what Roll says. We can state without reservation that this crucial anchor point in Egyptian chronology is our first real fixed point in history. The sacking of Thebes by Ashurbanipal in 664 BC, our earliest genuinely fixed dated Egyptian history. It's the earliest that they can go, that they fixed it and was certain. All Egyptian dates prior to 660 BC are an illusion. They don't have a fixed date for them. They just don't have it. Rowe also makes convincing arguments for the dating of events which demonstrate that the early date of the Exodus, which some claim to be from Egypt about 1450 BC, is the most reasonable date. The claim that it occurred in about 1250 BC has been disproven in this book by Rowe. And it's a pretty scholarly book. I think it's got some good arguments. His arguments should be studied by those who love the truth. I believe this is an excellent book to possess, and I prize my copy of it. The assumptions in dating the moon, for example, are based upon uniformitarianism. Let's go to the moon now. Look at it. We've seen the Egyptian chronology is about 664 BC is the earliest date that you can get with any certainty. Ages can be assigned to the geologic units of the Schrodinger basin, that's on the moon, by means of the density of superimposed small craters. So we're going to look at the superposition of units of various craters, and the superposition of the units themselves in their relation to various swarms of secondary craters. Cumulative crater frequency per square kilometer lies slightly below that of the Oriental basin, except for a few craters larger than 30 kilometer in diameter. For these data alone, Schrodinger would appear to have slightly younger than Oriental. Now, these are Oriental is a Latin word for the east. Okay, so remember that. Age is based upon the number of craters. So how do they date it? They say, well, we see impacts upon the moon, and so we see these impacts, and so we say it took this time. And so they're projecting what they see now backwards in time, uniformitarian assumptions. They've completely rejected the possibility there may have been a massive number of craters during the time of the flood or some other catastrophic event, even if they don't believe in the flood. But again, they've used uniformitarianism assumptions on the moon. Again, we have uniformitarianism keep popping its head up. This dating of the Schrodinger basin is based on the density of the craters. It's assumed by geologic dating that the Schrodinger basin, that the number of meters impacting the moon is constant, that there were no cataclysmic events. Even rejecting the idea of the flood, they've accepted cataclysmic events in geology. The thrust of the Fox flood model is that the moon experienced cataclysmic bombardment from space during the time of the flood, the roughly 1 year of the 150 days of the flood, about approximately half a year, about 180 days or so when this occurred. The atheist is in a catch-22 situation. That's a situation we'll explain that in just a minute, in that many have accepted catastrophism in geology, but continue to claim the dates derived from uniformitarian assumptions. See? But their dating is based on uniformitarianism, but they've rejected uniformitarianism. So catch-22 is a problematic situation for which the only solution is denied by a consequent circumstance inherent in the problem. That's a catch-22. And what's the circumstance inherent in their problem? The circumstance is they rejected uniformitarianism, yet they're using uniformitarianism to date it, to do their dating. They're between what we say in Oklahoma, where I grew up, between a rock and a hard place. It's a catch-22 situation. Here's a logical dilemma that they have. Either Earth's history has followed uniformitarian principles, or their history has followed catastrophic principles. Earth's history has not followed uniformitarian principles admitted by most scientists today. Therefore, any dating based on uniformitarian principles is flawed. Okay. Conclusion: flawed. It's flawed. Now let's look at the dating in central Mexico of corn. They call it maize, but corn, what we call corn in the United States. And so this is because the maize from central Mexico was dated in the same manner as that of Tamaulipas by arbitrary excavation levels. Grouped by zones, perhaps its age has likewise been more assumed than demonstrated. And what does it mean there? They've taken this corn and they've excavated it from different levels of the soil. And so they say, okay, this was put in, it was covered up over time, and so uniformitarian assumptions. They've made uniformitarian assumptions, different layers of soil. And so this assumption was made. The age has likewise been more assumed than demonstrated. So they hadn't demonstrated it. How do they know that it wasn't covered up in a cataclysm, or it wasn't covered up more rapidly than they've assumed? So they've made assumptions about it. It's based on assumptions. Even the excavation levels are arbitrary. Now we'll notice what he says. By arbitrary excavation levels, they've been arbitrary. They're arbitrary, grouped by zones. It's arbitrary. He admits it's arbitrary. That's Fritz. Fritz goes on and says, because the higher order analysis and interpretation depend for organization upon the early dating of the cultivated plants, the final results are inevitably thrown into question. So when we start to try to analyze this with the methods we're going to use, statistics and so forth, we got a problem because we've made these assumptions. So it depends on the organization upon early dating. We dated the early means with arbitrary assumptions. Did they assume it was this old based upon other claims, and then assume the layers of soil had to take a certain period of time to be deposited? Fritz admits that he's proven nothing. So our final results are inevitably thrown into question. We just didn't prove anything. Hartmann wrote, the discovery of the reversal of the Earth's magnetic field. Now we get to the magnetic field reversal dating. Could be fixed at 700,000 years ago, was used to set the relationship between the depth and time for ocean sediment cores. So the reversal of the Earth's magnetic field, whose date could be fixed. So we fix that date, And we've done it 700,000 years. How do we date that 700,000 years? Well, we assumed a constant sedimentation rate. Now, that is uniformitarianism, for crying out loud. That's what it is. Constant sedimentation rate is uniformitarianism. So how did they date these reversal of the Earth's magnetic fields? They did it by the sedimentation rate, assuming a constant sedimentation. I emphasize that. That's uniformitarianism. Again, they're just irrational. They gave up uniformitarianism, but they keep on using it for their dating. Now, Officer Drake tells us, although the time scale of magnetic reversal is no better in absolute time than the final radiometric or other clocks against which it is calibrated. So now what are they saying? Well, the magnetic reversals were dated by or calibrated by final, radiometric, and other clocks. What the other clocks would be the layers of the layers assumed uniformitarian sedimentation rates, uniform sedimentation rates. The final would be index fossils, and that's based on the assumption of organic macroevolution. Radiometric has its problems because you have 4 variables and you only know 2 of them. And one of them is kind of shaky. So you have to make assumptions. Again, they have no way of being certain about this. They've calibrated with a system that's within itself hasn't been calibrated. If a particular reversal event could be identified in 2 sections, then we know that the ages of reversal intervals are simultaneous to within approximately 10 to the 4th years. Now, 10 to the 4th power is 10,000 years. So now we have that situation. Now we come back here. They come to Varves, dating with Varves. A varve is derived from the Swedish word varv, whose meaning and connotation include revolution in layers or a circle. A circle here. The term first appeared, varved clay, on the first map produced by the Geologic Survey of Sweden in 1862. So that's where it appeared in 1862. Initially, varves was used to describe the separate components of annual layers of glacial lake sediments. But in the 1910s, Geologic Congress, the Swedish geologist Gerard de Geer, who died in 1943, proposed a new formal definition whose varve described the whole of any annual sedimentary layer. So he was assuming it's an annual layer. So notice that's an assumption of it. It's an annual layer. More recently introduced terms such as annually laminated are synonymous with varve. So annually laminated. Now notice annually, they're assuming this was laid down in 1 year. That tells you an inherent assumption in varves. They assume they were laid down in 1 year. So here varves, supposedly taking 1 year to put these layers into place. How do they know this took a year? How do they know that this didn't occur over successive overflowings and tidal actions of the flood? How do they know that didn't occur in that situation? Of course, sandy clay is supposedly formed when there's a rapid water motion. Right here, the coarse sandy clay. And silt layers supposedly formed when the lake is covered with ice, supposedly. And so that's supposedly what happens. That's an assumption. In addition to seasonal variation of sedimentary processes. Now then, forming of ice may form a silt layer such as this in the real world. That doesn't guarantee that that was the only thing that would form it. And so again, we have to go back in time. And again, it's not true science because they've got to make assumptions and they haven't observed it. They've observed that silt can be formed in this way. This can be formed in this way, but they're not proving that this was the way that it was formed in these rocks, in these barbs. In addition to seasonal variation of sedimentary process deposition, varve formation requires the absence of bioturbation. That's the bioorganism stirring up the bottom of the layer. Consequently, varves commonly form under anoxic conditions. That is, conditions where there's not much bioturbation or not many organisms to stir the bottom of the layer. So anoxic conditions where you don't have very many living organisms in it. So here's your fine silt layer and your coarse sandy layer. And I've got to show them laid out here for us, okay? Scarborough Bluffs in Toronto, Canada. And here's a picture of that, and here's what they look like. Well, how do we know these didn't form during the flood? We just don't have any way of knowing that. Scarborough Bluffs are on the shoreline of the present Lake Ontario. The bluffs are formed by glacial Lake Iroquois. Bluffs have been described as a geologic wonder. These bluffs have a unique feature in North America. So here's your Lake Iroquois, and that's where it was, right here. This is Lake Albany. This is out of the state of New York. We've looked at the Laurentide ice sheet and that formation at that time. Here's the varves on glacial Lake Missoula in Montana. So there's the varves there for that. And these layers. Now, if the winds blow the water back and forth over time, it could form this. Just because the top of the water is being moved around doesn't mean the bottom is necessarily moving that much. Here's the Lake Missoula, and there's the glacial Lake Missoula, and here's the flood path. When this ice dam was breached, it had just what we'd call a massive layer of water coming down. And this in layers of water, large sheet of water coming down. Dating by varves, let's look at them, is based upon the assumption that there's only one coarse grain layer and one fine grain layer deposited each year. That's, notice they call them annual layers. That's the assumption. And that's an assumption. Dating by varves based on assumptions when they have no real data. They have no way, they haven't gone back and looked at them 20,000 years ago. So they have no real data to prove it. But it's calibrated with radiometric methods. So they calibrated with radiometric methods, usually radiocarbon. Okay. There are a few sequences of strata, notably some Pleistocene lake deposits in middle latitude North America and Europe, some Eocene shales in Wyoming, and some Permian evaporates in Texas, whose thin cyclic lamentations are believed to represent seasonal variations in accumulation. Variations from year to year often permit sequences of varves to be matched with from one deposit to another. Again, it's like they did with their tree rings. They overlap them to get a sequence of time. And so they overlap them just like they did there. However, he goes on and tells us, Shelton does, like the analogous tree rings, these sequences are extremely limited from a geological point of view because they represent such short time spans, rarely more than a few hundred years at any one locality. So how do they get thousands of years out of it in such special localized conditions? Also, at some localities, there's uncertainty about the annual origin of the layers. We don't even know that these layers are annual, that they're annual rings or annual layers. And so there's uncertainty about that. And I say there's probably more uncertainty than they're admitting, but they do admit uncertainty here. And so we only get just a few hundred years out of them, and then they end. So they have to overlap them, make assumptions to overlap them. The record retreat of the last ice sheets in Europe and America have been traced by means of varves. Unfortunately, there are gaps in the records that can be filled in only by estimates. Oh, lovely. So they have to make some assumptions to get their estimates. So it's estimated. In Scandinavia, a connection with the present has been established in the Barbs chronology with certain portions estimated. I've got that underlined. It wasn't underlined in the original. I underlined it. Extends from the present to about 10,000 to 15,000 years ago, but there are estimates in here. So they made estimates. So they took these barbs and went maybe 400 or 500 years, and then they made some estimates. Again, I'm not going to accept their estimates. There's no real data to substantiate what they've claimed. Stokes tells us in North America, the Barb chronology, again, with some estimated portions, reaches back some 20,000 years. Again, they make estimates. In view of the uncertainties and imperfection of the method, it's impossible to say exactly how far back continuous Barb records go. It's impossible. Again, I don't accept their dates. They got estimated, impossible, and uncertainties. Note the words estimated, impossible, and uncertainties. That ought to get you going good. We have uncertainties, we have impossible, and we have estimated, uncertainties, impossible, imperfections. They're imperfections of the method. Older barbs yield year-by-year records. This goes on and says, for limited parts of the geologic column, but not ages. They don't give us ages, actual age in years before the present. For these and other truly ancient rocks can be obtained only from methods involving radioactive decay. Now that's what the claim is made. We have to go back to radioactive decay. We have to use radiometric methods to date it. But remember, there's 4 variables in the equation for radioactive decay. I will give them that they can make a fairly accurate measurement of how much radioactive isotope they have now with their methods. But then they have to assume that they truly know the decay rate. Let's just give them that point for the sake of argument. Just for the sake of argument, however, they still have to make an assumption about how much of the radioactive isotope was there initially. And it's not science because they did not observe it with any method. Didn't observe it. So it's not science at all. They have made assumptions. We go back to the assuming. Dating always goes back to radioactive methods, radiometric methods. That's where it goes back. The geologic sequences, recent sequence of events on Earth, including the evolution of man and other metazoan life, were deciphered in detail in the last half century by systematic techniques, especially in understanding of geometric interrelations of minerals and rocks, the correlation of strata by mapping, and the use of index fossils. Index fossils based upon assumption of organic macroevolution. In contrast, conclusions regarding the rates and dates of most Earth events, their worldwide correlation to the source of the Earth's enormous eternal energy were largely intuitive and erroneous. Prior to the discovery and understanding of the radioactivity of the Earth, we assumed some things about it. They had a problem with it initially. This was a big Lord Kelvin was one of the great scientists of his time, and he argued that from the Earth itself, it started out molten, how long it would take it to actually get to where it is now. And he come up with a much shorter time than we have. And so they had to come up with some way to explain that there's had to be something generating heat in the Earth. It should have cooled off a long time ago. Gone completely, basically the same temperature throughout. But they argued that radioactive material in the core of the Earth is generating the heat. And so that's how they got to this longer period of time. They didn't Lord Kelvin argued against it for a while, but he finally gave up with the claim that radioactivity was generating the heat in the Earth, to decay of isotopes. He's saying that they were just guessing or following their intuition, but now they have a technique that absolutely dates things, radiometric dating techniques. But that's a false assumption. It's not even scientific, because they have to assume what the initial value of the isotope was, how many there were. And they have to assume that they have the actual decay rate of the isotope itself. Their intuition was guided by their worldview, which was materialism. They were materialistic, they were atheistic, and that's what guided their intuition. The worldview of materialism demands that the explanation of the existence of living organisms be explained by purely materialistic methods, organic microevolution and uniformitarian geology. It takes uniformitarian geology to get the time to have the organic microevolution. That's why they can't give it up. Materialistic worldview, by definition, refuses to consider any theistic interpretation of natural things. Cannot be a theistic, a God-centered interpretation of natural things. Batchelor tells us, page 289, the radiocarbon dating measurements of burnt wood from the nutbane long barrel has recently been completed. This charcoal has given the satisfactory and interesting carbon-14 date of 2721 plus or minus 150 BC, a date which must assign our windmill hill cultures to a rather earlier position than that which has been accustomed to place them. So now we had a problem. We use radiocarbon, and the dating we come up with, it just won't fit what we're accustomed to. They're in a quandary. And this has happened more than once. It's just happened over and over. The moon rocks found by the Apollo astronauts are dated by radiometric dating techniques. Burgess tells us the ages of lunar rocks derive from the various methods of dating. For example, rubidium, strontium, potassium, argon, and lead, uranium, thorium ratios. So these ratios, you'd think, well, they got the ratios of several different isotopes. They still have to assume how much of each isotope was there in order to begin their assumption. It still goes back to an assumption of how much the isotope was there. And a second assumption that you really truly know the decay rate of it. And the third assumption that nothing could vary that decay rate, such as a large amount of neutrinos hitting the Earth, changing that decay rate, causing it to decay faster. Here's your equation again. We come back to it. And so we have four variables, n sub t, and we'll give them that point that they can get a pretty accurate measurement of that. N sub o, they have to assume that. Epsilon, that's known, that's a constant. Lambda is your decay constant. Again, we've given evidence that that can be variable. And there might be other factors that we don't even know about that could change the decay constant. And of course, time itself, that's what they're looking at. But again, they have four variables, they only know two of them. And even one of those, there's doubt about it. And so they have to assume the third variable, n sub o, they have to assume the initial quantity of the substance. Again, they haven't proven anything by this. Four variables, they only know two of them. They got to know three to get a unique solution. I mean, a high school mathematics student who's taking algebra 2 in high school should know better than that. The decay constant is not as fixed as they claim. Initial value of the radioactive is not known. They have to assume it. There's no unique one single solution for the equation. There are an infinite number of solutions. I've already shown this before for the value of time. A student who earned an A in algebra 2 in high school should know better than this. Cox tells us the first quantitative timescale for reversals, this is reversals here of magnetic field, was achieved in 1963 by measuring the ages using the potassium argon technique. Again, how did they measure it? Well, they measured it by radiometric dating and the magnetic polarities of young volcanic rocks. This work appeared to confirm earlier paleomagnetic results from undated sedimentary rocks, which indicated that all polarity reversals were of nearly equal length. All your polarity reversals were nearly equal length. Got a problem here. Cox tells us this is an assumption. They were of nearly equal lengths. How did they draw that conclusion? They dated it from sedimentary rocks. How do you think they got that? By the thickness of the rocks. They've assumed a thickness of the rock based upon assumed uniform deposition rates of the rock, the sediment. Dating was determined in 1963 before geologists rejected uniformitarianism. So the geologists, pardon me, rejected uniformitarianism after 1963. So this dating here was based on uniformitarian assumptions. He's still using uniformitarian assumptions, which they have rejected. And again, that's amazing to me that these men can call themselves scientists. The Pleistocene geomagnetic polarity timescale based primarily on the KR potassium argon dating and paleomagnetic polarity determination of igneous rocks, that's rocks generated by heat, is given in figure 9-2, page 211. Analytical uncertainties that are inherent in radiometric dating generally limit application of this dating and polarity determining technique to the past 5 million years. So this technique can only go back about 5 million years. It's inherent. Analytical uncertainties are. If you get to a certain point, you don't have enough of the material left to really date it. Here's some assumptions in dating magnetic field reversals. At an absolute age of 5 million years, million annum, A for annum being a year, the typical era in radiometric age determination approaches the typical duration of polarity reversals. You go back to the polarity reversal in about 5 million years. Okay. Paleontologic dating of sedimentary horizons, sedimentary rock, they dated it by the assumed constant for sedimentary deposition rates. Dating of sedimentary horizons is required to determine geologic ages, so we got to date it by the assumed sedimentary deposition rate. In correlation to the radiometric dating polarity sequence is required to estimate absolute ages within individual deep sea cores. What's he saying? He's saying we assumed a deposition rate, a constant deposition rate, and we use that deposition rate to calibrate our radiometric ages. And we use that to determine the ages of these reversals of magnetic fields in the rocks. That's what we did. No catastrophic events occurred. No catastrophism whatsoever. If they have an error, 100% error at 5 million years, how can they date things older than 5 million years? They can't. The spreading of the C4 is extrapolated with linear extrapolation. That is uniformitarian. Backwards, the linear would be, it goes at a constant rate. Backwards for 5 million years by their dating technique, and then the rate of the spread is extrapolated backwards in time. Butler tells us that on pages 215 to 216. Constant rate of C4 spreading is uniformitarian is assumed. Since atheists have rejected uniformitarianism, one essential assumption of their dating technique is not true. And the whole system is in question. Clearly, seafloor spreading cannot be dated anywhere near 5 million years ago. It's got 100% error at that point. But they've assumed uniformitarianism all along. The public school textbook in the Western world, the United States specifically, in our kindergarten through 12th grade are still teaching uniformitarianism. After 13 years of indoctrination, brainwashing, most of the students do not take any more science, and they are so brainwashed that they ignorantly do not even know that the atheists have lied to them in the public schools. They have no way of knowing it, and they swallow it hook, line, and sinker. Even the teachers of public schools are unaware of the dilemma of atheistic materialism. Uniformitarianism is not true, then the dating systems are flawed. That's clear. Even radiometric dating begins with uniformitarian assumptions. It's calibrated with uniformitarian assumptions to determine the value of the initial value in SIVO, the amount of material radioactive isotope at the beginning of when they measured. Again, NSIVO is assumed and they calibrated with uniformitarian assumptions, determined by uniformitarian assumptions. Go back in time, with uniformitarianism. They used linear extrapolation techniques to determine the ages of polarity crons in the Paleogene were predicted by an assumed constant C4 spreading rate of the South Atlantic Ridge, Butler tells us. Constant sedimentation deposition. A constant spreading rate that is spread at a constant rate. No catastrophic events occurring. Cores that were dated by the fossils in the cores, Butler, page 218, were then drilled into the ocean floor, and the crons, that's my system for measuring time, were dated by the fossils, index fossils, right, which we've already talked about in prior lessons. The whole system based on substantive uniformitarian geologic rates, clearly. If substantive uniformitarianism is untrue, the whole dating system is unsound. We keep coming back to it. They don't have a leg to stand on, we would say. So let me summarize this quickly. All your dating techniques have flaws in them that are used by these atheists, by the scientists, by the scientific community by and large. And so the flaws are there. And in radiometric, they've assumed that they know the decay rate of the isotope, and they have to assume how much of the isotope was at the beginning, which they cannot verify by empirical means, therefore it's not scientific. And then they've assumed uniformitarian deposition rates for the sediment and for the spreading of the ocean floor and other things. All of this have assumed it, and it's been based on uniformitarian assumptions, which they've rejected. The whole system is flawed. I would ask, are there any questions that anyone has at this point?